lesson 10.4, page 430 for you 8th grade general students, and lesson 16.4, page 730 for you 7th accelerated students. We are continuing on the unit of exponents and scientific notation. Today is our last lesson on exponents, where today we're going to use the definitions of zero and negative exponents to evaluate and simplify expressions. Our essential questions: how can you evaluate a non-zero number with an exponent of 0? And how can you evaluate a non-zero number with a negative exponent? Now, ladies and gentlemen, I know you are persons of character, so you already went to the appropriate pages and you wrote down the notes. First, for zero exponents. So you should have written something like this. For any non-zero number, a raised to the 0 power is equal to 1. So a power with an exponent of 0 is always equal to 1. The numerical example they gave was 4 to the 0 is equal to 1. The algebraic example was a to the 0 is equal to 1. And of course, a cannot be 0. So any non-zero number, any non-zero variable, if that variable does not have a value of 0 and raised to the 0 power, then it is equal to 1. So we can use our previous exponent rules to help us with this, because right here I just pulled up an example that says I have x to the 5th times x to the negative 5th. And a reminder, what do we do with exponents when we multiply with a common base? Yeah, you're correct. We add them. So this is equal to x to the 5 plus a negative 5. And we know that that's x to the 0. Well, we just learned x to the 0 is equal to 1. So our final answer is 1. Over here, we have another example. X to the 8th divided by x to the 8th. Well, I'm sure you already know that is equal to 1, because anything divided by itself is equal to 1. But using the property of exponents that we've learned, what do we do with those exponents when we're dividing with a common base? You are correct again. We subtract them. So this would be x to the 8 minus 8, which equals x to the 0. And again, x to the 0 is equal to 1. A couple more quick examples. When we evaluate these expressions, we have 8 to the 0. This one's tough. It's 1. Anything to the 0 power is 1. If I add x to the 0, we just talked about it. It's 1. If I have m to the 6 times m to the negative 6, this gives us m to the 6 plus a negative 6, which equals m to the 0, and it is equal to 1. Anything raised to the 0 power is equal to 1. And 5 to the 7th divided by 5 to the 7th, that would be 5 to the 7 minus 7, which equals 5 to the 0, and of course, that is 1. Alrighty, let's move on to our next one. So hopefully you have already done that as well. If you haven't, pause, go to your book, and write down those rules of exponents for a negative power. All right, or excuse me, a power with a negative exponent. And when you do that, it should look something like this. For any integer n with a non-zero number, a to the negative n is the reciprocal of a to the n. Well, that doesn't make a lot of sense to me. Probably doesn't make a lot of sense to you. So let's take a look at the examples and see if we can figure that out. It says that if I have this 4 to the negative 2, I have a power 4 with a negative 2 exponent. It's saying, hey, all I have to do is take the reciprocal of that power and make the exponent positive. So 4 to the negative 2 would be 1 over 4 squared, or 4 to the 2. You also need to know that what if that negative exponent is in the denominator? Like if I have 1 over 4 to the negative 2. Well, you take the reciprocal and make it positive. And the reciprocal of 1 over 4 to the negative 2 would be 4 to the 2 over 1, which is just 4 squared. And of course, if you had to finish that, we would get 16. Algebraically, it's the same thing. A to the negative n gives us 1 over a to the n. We make it positive and take the reciprocal, where a is not equal to 0, of course. And naturally, if I have 1 over a to the negative n, I take the reciprocal and make it positive, I would get a to the n. So, ladies and gentlemen, let's take a look. X to the 5th times x to the negative 9th. Once again, we're multiplying with a common base. So we would have x to the 5 plus a negative 9. That would give us x to the negative 4th, which we now learned. We take the reciprocal and make it positive. 1 over x, make that exponent positive. 1 over x to the 4th. And the same thing if we're dividing x to the 8th divided by x to the 15th. Well, that would equal x to the 8 minus 15, using our rules for dividing powers with the same base. This would equal x to the negative 7th. We take the reciprocal, 1 over x, and make that exponent positive, 1 over x to the 7th. Let's do a couple examples here. We have 8 to the negative 2, and we're going to just go with this rule. Write answer as a power. If they didn't ask that, then you'd actually have to do the math with this one. 8 to the negative 2 would equal 1 over 8 squared. Take a reciprocal and make it positive. Of course, if they didn't say write the answer as a power, this would be 1 over 64, right? If we have 1 over x to the negative 3, taking the reciprocal, that would be x to the negative 3 over 1. You want to make it positive, so that's x to the 3rd over 1, which is nothing more than x to the 3rd. Right? That's a lot of extra work. You don't need to go through all that. You should know. Take the reciprocal, make the exponent positive. M to the negative 6 times m to the negative 3rd. M to the negative 6 plus a negative 3 gives us m to the negative 9th. Taking the reciprocal and making that exponent positive, 1 over m to the 9th. And our last example, 5 to the 7th divided by 5 to the 11th. So we're going to take 5 to the 7 minus 11, because we subtract when we multiply, or divide, we subtract when we divide powers with a common base. This is equal 5 to the negative 4th, which one more time, you take the reciprocal when it's negative, 1 over 5 to the 4th. Of course, if you were actually asked to do the math, that would equal 1 over 625. Alrighty, ladies and gentlemen, your first quick write. Pause the video so you can write all that down and get that done, because I'm going to continue on with this video set of notes, going right in, because we're going to just do one video tonight. Simplifying expressions. Write the expression using only positive exponents. Number 9 says negative 2 times x to the 0. Well, the first thing you know, using the order of operations, GEMDAs, x to the 0 is equal to 1. This gives us negative 2 times 1, which is equal to negative 2. Pretty straightforward. We're not going to get too complicated with this stuff. Example 10, 4b to the negative 4th divided by 2b to the 7th. So we take one thing at a time. So we're going to take these coefficients. 4 over 2 is equal to 2. And then we're going to take b to the negative 4th divided by b to the 7th. So this would be b to the negative 4 minus 7. So we would end up with 2 times b to the negative 11. Well, we can't have negative exponents, says use positive. So we're going to take this one. The 2 is not part of that power. It is the coefficient. So our final answer would be 2, taking the reciprocal of b to the negative 11 and making it positive. We have 2 over b to the 11th. Ladies and gentlemen, moving right along, let's do a real life application. A drop of water leaks from a faucet at a rate of 4 to the negative 6 liters per second. How many liters of water leak from the faucet in 1 hour? So, knowing that, first thing I'm going to do is I'm going to take this 4 to the negative 6. And I'm going to evaluate that one. And I'm going to say this is 1 over 4 to the 6th. And 1 over 4 to the 6th happens to be 1 over 4,096. Well, now, that doesn't help me a lot. That's 1/4,096th of a liter. That doesn't help me. So I'm going to turn that into a decimal by dividing 1 by 4,096, and I get 0.000244141. Wow. That much water of a liter leaks from the faucet in 1 second. So I'm going to write that. 0.000244141 liters per second. Now I have to turn this into how much is going to leak in 1 hour. Well, the first thing I have to do is multiply by 60 seconds in 1 minute. When I do that, I can cross out the seconds. Then I'm going to multiply that by 60 minutes in 1 hour. And from there, I can cross out the minutes. What am I left with? Liters per hour. Hey, that's what we want, liters per hour. Now I actually have to do the math, taking that big long decimal, multiplying it by 60 and multiplying it by 60, and I get 0.8789, and that's a lot. And there's more decimals. I'm not going to go any further than that. I'm going to round to the nearest hundredth, and I'm going to say that's 0.879 liters per hour. So almost 90% of a liter. Not quite a liter, just less than a liter. Well, there we have it, ladies and gentlemen. We've done our examples. We have one more quick write. Go ahead and pause the video and see what you can do. Just remember, divide everything up. After you write this down, you're going to do each common base one at a time, following the rule with that, so that you can then come up with the final answer using all the rules of exponents that we have learned. Thank you so much. Take a break after you get the quick write done, and I'll see you tomorrow. Make sure you write down any questions that you have so you can ask them tomorrow in class during our revisit.